So the third one was at 2f1, and the object was at 2f1. The image was also at 2f1. So the image was real,
F2.
inverted, and of the same size.
Sir, image is
Isn't
at
it?
2F.
Sir, at 2F2.
2f2. Oh, sorry, 2f2. So the third, it was third. The fourth was between
F1 and 2F1.
F1 and
f1 and
2F1 and
2f1. And next, it was beyond 2f2.
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 So this was the diagram. I think I had drawn these three. Did I draw these three?
Yes, sir.
What? How was this diagram? So optic center, F, F, 2F, 2F. So 1, 1, 2, 2. So the fourth one is between F1 and 2F1. If the object is here, one ray hits the, which is parallel to the principal axis, and it passes through F. Another one which moves through the optic center. So both of the rays will meet here. If AB is the object, A dash, B dash is the image formed. So this is the object, this is the image. Look at the image. Do you think object and image are on the same side?
No, sir.
They are different sides. If they are different sides, then different side, then they are real, and the object is inverted. And look at the size. The size is
Magnified.
enlarged, magnified or enlarged image equal. This is for the between f1 and 2f1. Next, at
At 1.
2f2.
F1.
F1.
This will be
F1. At F1.
at f1, and the object is at f1. This is the ray diagram for that. So optic center, f, 2f, f, 2f, 1, 1, 2, 2. So the object is at f. So here also the ray which is parallel to the principal axis, it then passes through the and moves away. Similarly, a ray passing from O and moves away. Where will they meet?
At infinity.
At infinity.
They will meet at infinity. So wherever they meet, you can see that it is below the principal axis only. So it is on the right side, it is real image. It is inverted and it is highly magnified or highly enlarged images formed. So these are the very important, very important ray diagrams. All of you must practice all these 1, 2, 3, 4, 5, and there is one more 6, 6 plus 6, total 12 ray diagrams. Please practice them. They are very important. Even they may ask you the problem depending on that also. I will show you what the problem means. What was the last one? Last one is
Between F1
Between
and
F1 and O.
between F1 and optic center O. So how is the ray diagram? This is O, F, F, 2F, 2F, 1, 1, 2. So when the object is placed here, as you can see, it goes and passes through F, and it goes through O. Do you think these two lines will meet anywhere? Are they moving near to each other or far away from each other?
Far away.
far away.
They are moving far away. So we will extend this. We will extend and they will meet somewhere here. So do you think the image is formed on the same side or on the opposite side?
Opposite side.
Same side.
Same
Same
side.
side or other side. Object is here. Image is also on the same side. Means it
Yes.
forms a. So here you can write position of images on the same side. So it will be virtual. ಯಾಕಂದ್ರೆ ಲೆನ್ಸ್ ಹಿಡ್ಕೊಂಡು ಹಿಂಗ್ ನೋಡಿದ್ರೆ ಐ ಹ್ಯಾವ್ ಟು ಸಿ ವಾಟ್ ಎವರ್ ಈಸ್ ದೇರ್ ಆನ್ ದಟ್ ಸೈಡ್ ಬಟ್ ವಾಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್ ಹಿಯರ್ ಇಟ್ ಈಸ್ ವರ್ಕಿಂಗ್ ಲೈಕ್ ಅ ಮಿರರ್ ತರ ಆಗಿದೆ ಆಬ್ಜೆಕ್ಟ್ ಅಲ್ಲೇ ಇದೆ ಇಮೇಜ್ ಅಲ್ಲೇ ಇದೆ therefore it forms a virtual image. Mirror is opaque ಆ ಕಡೆ ಕಾಣಿಸಬಾರ್ದು ನಮ್ಗೆ but lens is a transparent material. I have to see whatever is there on that side. So ಈ ಕಡೆದ ಆಬ್ಜೆಕ್ಟ್ ಆ ಕಡೆ ಕುಂತ್ರೆ ಕಾಣಿಸ್ಬೇಕು ನಮ್ಗೆ ಆದ್ರೆ ಕಾಣಿಸಲ್ಲ. If you keep in between these two it cannot be seen. So it is virtual. Now tell me whether it is inverted or erect image.
Erect image.
Erect.
Erect image. And look at the magnification noted. Is it small, diminished or magnified? It is also enlarged image is formed. So that's it. These were the 6 ray diagrams of the convex lens.
Sir,
Yes.
sir, can we write the position of image as behind the lens?
Yes, behind the lens only. On the same side means it is behind the lens. Behind the lens. Both are on the same side. Means same side of the object, or it is behind the lens. All right. Any other doubt you have to draw or something of all these? Another doubt is there to draw the diagram of these ray diagrams. So quickly take them. We will further do the next lens. What is the next lens?
Concave lens.
Concave lens. We'll see how are the ray diagrams of the concave lens. Don't know why they have cut the power today. Shall I rub this?
Yes, sir.
Yes, sir.
Just like how we had in the mirror only 2 positions of the convex mirror, similarly of concave mirror also we have the same thing. What are those? Position of object, position of image, and their properties. The first one was when the object is at infinity. Second one, between infinity and optic sync. Only these 2 positions. Let us see how are the ray diagrams of the first one. Optic center, F, 2F, F, 2F, 1, 1, 2, 2. When the object is at infinity, the rays comes here parallel to the principal axis, and what happens to them? They will get diverged. So we do not get any image on the right side. So what we do, we will bring them back and the image is formed here. Where is the image being formed?
At F1.
At F1.
The image is at F1. As you can see, the object as well as the image is on the same side. Therefore, we can write it is virtual image. It will be erect image, and the size is point size. This is for the first one. The second one, optic center F, 2F, F, 2F, somewhere anywhere between infinity and O, anywhere it may be. It may be on 2F1 also, 1, 1, 2, 2. It may be at F1 also, it may be between O and F1 also, anywhere. So I have just taken it here. So when the rays goes and hits, they diverge and the rays passes through optic center. So both are divergent rays, they will not meet anywhere. So we have to bring them back. So somewhere here it is going to meet. It is the object. So what are the properties of the image here? Where is the image found? Image element.
At F1.
Beyond
Between two
F1.
F1 and F1.
It has to be between F and O, no? The object has to come
Sir.
between F and O, I guess. Correct, Jainagila. It will pass and we will take it. Here it comes AB, A dash, B dash. The object is formed between F1 and O. F1 and O. And the image is virtual, image is erect, and the image is diminished. So these are the two ray diagrams of the concave mirror. Anywhere you keep the object, anywhere you can keep the object, it will form between F1 and optical center, diminished, which is virtual, and it is an erect image. So if you have any doubts regarding this, you can ask me, or else straight away we'll move to the sign convention. Shall we move to the sign convention?
Sir.
Yes.
Sir, why when the object is at infinity, it is not passing through optic center? Why, sir? The ray is not passing
When
through
it
optic
is
center.
at infinity, no? When it is at infinity, when the object is there, see the type of rays coming from the object, we have to consider from the ray, it can also come from here. No doubt it will not come, but it will straight away pass and move out. Straight away it will pass and move out. Let me draw it properly. Because here we will have the starting point and end point. But when they are at infinity, infinite position, they will not have the starting point. Object is somewhere else. We don't know, very far it may be. Infinite in distance means you don't think for 5 kilometer, 10 kilometer it will be. You cannot see anything which is so much far. It is farther than the 2F1. Beyond means somewhere very nearby. 2F1. Beyond that point, we can consider if the focal length of this lens is, if the focal length of this is 10 centimeter, then definitely it will be 10 centimeter here. Suppose it is 25 centimeter, we can call it as beyond 2F1. If it is at 35, 40 centimeters away, that we call as infinity. It is so much far. So from there, if you want to bring, if the object is bigger, if you want to bring, straight away it will pass through optic center and move away. And still we cannot tell they will meet, the rays will meet, they will move away from each other. So we do not consider the ray coming and passing through the optic center. Okay?
Sir, it's not change anything, no, sir.
It will not change anything. What it will change? Just see, to draw a ray diagram, there are so many millions of rays falling down actually. Millions of rays fall on the lens, fall on the mirror. But we consider only two types of rays, any two types, where they will meet. But when it is at infinity, we consider only the lines which are parallel. We consider only those lines. Because lines which are coming from large distance, from very long distance, no, we consider them to be parallel. Understood? Suppose we are standing here and we want to look at the ceiling of our building. So we will make an angle. There will be deflection. But if you want to see the ceiling of somebody's house which is very far away, our face will not change. If we are near, then only there will be an angle. If it is far, there will not be any angle. Are you getting?
Yes, sir.
So the objects, the rays from the objects which are coming from a long distance, those rays we consider only the parallel rays. Not only in these two, even in the mirrors also. Only parallel rays are taken for the infinity purpose. If it is nearby the lens, we consider other rays also. Did you see while we were drawing the ray diagram of the mirror, we considered one more ray. So if it is here, we considered this one more ray which is passing through the center of curvature. Did you see? And we considered a ray which is passing from here. So both will go and meet. So this is how we tell them. Understood? But
Yes.
we have to consider the ray here which passes through F. That is important for us. It has to pass through F when it refracts. Even while reflection also we consider the same till only the last part. Last part only we consider only one. You know this. This is pole FC. When the object is here, we consider this ray. Isn't it? And we consider the ray which hits the center of curvature. And we tell that these rays will never meet. So we will extend this, we tell that image is formed inside. So the rays which we choose have to be perfect ones. We have 4 types of rays we studied in the ray diagram of the mirrors. We studied 3 types of the rays here while studying about the lens. Before refraction parallel, after refraction parallel, and the ray which is passing through optic center. Only for infinity, we consider only parallel rays. For other purpose, we consider 2 different types of rays only. Got it?
Yes, sir.
Okay, let's move to the next numericals. Numericals are very important in this. Let us understand numericals with the help of diagrams also. Okay, so numericals on refraction. Let us see the question. Just with the question only, we'll draw the diagram. With the question, we'll draw diagram, and you can assume with the help of the table, and whether it is similar to our problem or no, we shall verify. Because for 5 marks question, sometimes what they will do, they'll give a problem and they will ask you to verify it with the help of diagram. Okay, so let us learn the numericals of this. For this, you need to learn lens formula. What is lens formula? 1 by F is equal to what was
by
mirror
V
formula?
minus by
1 by V.
Mirror formula was 1 by F equal to 1 by U plus 1 by V. For lens formula, it is 1 by V minus 1 by U. You can check on Google how did they formulate this. How did they formulate this? This also they have used mathematics to formulate how did we get 1 by F equal to 1 by U minus 1 by V. How the object distance and image distance is minus here. Okay, the reciprocals of the image distance and object distance is negative. We are finding the difference of these two, and that will be the focal length, the reciprocal of the focal length. Even the magnification formula, what was magnification formula there?
Minus
By
V by U.
there we had minus V by U. Here for magnification we have just V by U. As you can see, there is a change in this formula. So this minus cancelled the minus here. So we got V by U. So a few more other concepts you understood. Just it is similar like the concave and convex. If you think about convex maximum times it forms real image, isn't it?
Yes, sir.
Convex lens maximum times only except for the last part, last between F1 and O, it forms the real image only. So real image means object will be on the left side, image will be on the right side. So right side means you will consider F is always positive. F is always positive. For the concave, which forms virtual image, where F is considered to be negative. So you need to remember this before we solve. Just think. Convex. Okay, this is convex. It has formed real image always. So F is positive. So here it has formed virtual images, which is considered to be negative. Even in the concave mirror also it was the same, no? Concave mirror also F was negative. Turn the pages and tell me. Concave you had written F negative.
Yes, sir.
Yes, sir.
Convex considered positive only. Same with the mirror as well as the lens. But the problem, the difference is in concave mirror, it formed real images. Mirror formed real images, but lens will form virtual images. Whereas in the convex mirror formed virtual images, where the lens forms real images. Is it clear?
Yes, sir.
Next, we'll talk about V. We'll talk about V. If V is positive, positive means right side. Right side means it forms real image. If V is negative means on the left side. Left side means it forms virtual images. Is that clear to you? Similarly with the M also. If M is positive, ನೆನಪಿರ್ಲಿ the M positive ಅಂದ್ರೆ ಮೇಲೆ ಹೋಗುತ್ತೆ. Sign convention when we were discussing, do you remember? Left side we considered negative, right side we considered positive. Above we considered positive, below we considered negative. These are the sign conventions. Graph ನೋಡಿದಿರಲ್ಲ? This is the graph. Towards the left it is negative, towards the right it is positive. Towards the bottom below the line is negative, above is positive. Similar to that it is. So M positive andre above means what type of image is formed? Erect or inverted? Male one.
Erect.
Erect image. If M is negative, then what type of image is formed?
Inverted.
Inverted.
Inverted. So now let us look back at the numbers. If M is equal to 1, magnification is equal to 1, andre object size image size ಎರಡು ಡಿವೈಡ್ ಮಾಡಿದಾಗ 1 ಬಂತಂದ್ರೆ don't you think both are same size?
Yes, sir.
Yes, sir.
Object is 10 centimeter, image is also 10 centimeter. If you divide 10 divided by 10, you will get 1. So 1 means it is of the same size. If M is greater than 1, andre numerator ದೊಡ್ಡದು, H dash is bigger. H dash means it is size of image. If image is bigger than this, image is bigger than the object, we can tell it is enlarged or magnified.
Magnified.
If M is less than 1, means the object is bigger than the image, denominator is bigger, so it is called as diminished. So this was with the numbers only, this was with the sign, and this was with the V, real image, virtual. So we are writing the properties, no? What property do we write? Looking at the number itself, we will tell beyond F1, beyond F2, everything will come to know when we start solving the problems. Just take all these in your book, we'll start to solve problems.
Yes, sir.
Done? Everybody took?
No, sir.
Hmm. How many have joined the class? What's the number it shows?
42, sir.
42. 42, sir.
We got the power now.
Yes, sir.
Remember these when we are solving problems. This time we will draw the diagram and we will understand with the help of diagrams. Numerical 1. A concave lens has focal length of 15 centimeter. So which they have given concave lens f equal to 15 centimeters. Come on, tell me the sign now. Concave lens will have positive sign or negative sign? F.
Negative sign.
Negative.
Negative. So concave lens has a focal length of 15 centimeter. At what distance should the object from the lens be placed so that it forms an image at 10 centimeters? So the image is formed at 10 centimeters. Image means V. Isn't it? Concave forms real image or virtual image?
Virtual.
Virtual image.
Virtual means V should be positive or negative.
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 So minus
Negative.
10 centimeters. At what distance U should be kept? And tell me, always U should be negative only. Remember, for mirror as well as lens, U will be always negative because it is at the left side. So let us start with the lens formula. So let us draw the diagram here. So it is concave. It has the focal length of 15 centimeters. Means the distance between this two is 15 centimeter. So if I take this is f1, f2. Similarly, this is 15 centimeters. Then it is 2f1. It is 15. From here to here, it will be 30 centimeters. Is that right? Focal length itself is 15. 2f1 means double, it will be 30 centimeters, where the object should be placed so that I get the image at 10 centimeter. 10 centimeters means where it is. It has to be formed between these two only, no? F1 and O.
Yes, sir.
Yes,
Is
sir.
that right?
Yes, sir.
10 centimeters from optic center means it has to come somewhere here. The image has to come here, A dash, B dash. Where is the object? You tell me with the table. If the image is between F1 and O, where is the object?
Behind the lens.
Huh? Object.
Between infinity and O.
Between infinity and O, wherever it can be. Okay, let us check where it is actually. So the formula 1 by F equal to 1 by V minus 1 by U. Substitute minus 1 by 15 is equal to 1 by minus 1 by 10 minus 1 by U. So minus, I'll take this to the left side. Minus 1 by 10 becomes, or we'll do reverse
Plus 1.
process. Wait, U is negative, no? So I have to make it positive. So I will take this to the left side and that to the right side. Minus 1 by U becomes plus 1 by U is equal to minus 1 by 10 plus 1 by 15. LCM?
30.
10 3s are 15 2s are. So minus 3 plus 2 1 by U. So 1 by U is equal to minus 3 plus 2 minus 1 by 30. Reciprocal U is equal to minus 30 centimeters. So the object should be placed at 30 centimeters from the optic center. We have to write the answer. Got it? The object should be placed at minus 30 centimeter. Image kottidaro. They have given the image. Remember, let me read the question once again for you. A concave lens has focal length of 15 centimeter. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter? The image forms at 10 centimeter. Did you understand? So at last, also find the magnification produced by the lens. You have to find also the magnification. M is equal to formula
minus V by U.
V by U.
only V by U. Minus V by U is for mirror, which is equal to M is equal to what it will be? V is minus 10 divided by U is minus 30. 0, 0, minus, minus, it will be 1 by 3. 1 by 3 means it is 0.33. Look at M. M is positive or negative?
Positive.
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 Yeah. M is positive means
Erect. Image is erect.
erect. M is greater than 1, less than 1, or equal to 1.
Less than 1.
Less than 1.
Less than 1.
What it shows?
Diminished.
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 Diminished image is formed. See, just by M, you have to see the sign and forget about it. Then numbers you have to think and tell whether it is magnified or diminished. So I hope you understood this problem. We'll solve one more.
Yes, sir.
So what about the diagram? Diagram is 30. It has to be kept at 30 centimeter. 30 means it is kept at 2f1. It is kept at 2f1. So the lens is small for us. AB, the ray which is little bit bigger goes through optic center. If you take it back, they will meet here. So this is your object. So for this, you might be asked for at least 5 marks question, 4 to 5 marks question, because you have drawn the diagram for that and you have solved and found the answer also. Take down. So what this means? 1 by 3 means you can substitute here. So M is equal to 1 by 3, which is equal to H dash by H also, no? M is equal to, you had written that. H dash is 1, H is 3. What it means? What it means? If the
Image and
object
object.
is 3 centimeter, if the object is 3 centimeter, image will be 1 centimeter. If the object is 30 centimeter, image will be
10.
10 centimeter. Means the image is 1/3 the size of the object. The image is 1/3 the size of the object. That also you please mention. The image is 1/3 the size of the object. Problem number 2. Let me read the question. 2.0 centimeter tall object is placed perpendicularly to the principal axis of a convex lens. So first let us write it is convex lens. So they have given 2 centimeter tall object. Object means what we will take? Which alphabet? Height of the size of the object?
H.
H.
H. So H is equal to 2.0 centimeters. Perpendicular to principal axis of a convex lens of focal length 10 centimeter. So F equal to 10 centimeter. Convex lens has positive or negative focal length?
Positive.
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 Okay. The distance of the object from the lens is 15 centimeter. The object is placed 15 centimeter from the lens. Means U is equal to 15 centimeter. Positive or negative?
Negative.
U is always negative. U is always negative because it will be always on the left side of it. Find the nature, position and size of the image. Also find its magnification. So let us draw this diagram now. Shall I draw the diagram or no? You will understand it clearly. So this is the optic center. This is F1, 2F1, F2, 2F. So the distance between these two is focal length. What is focal length? 10 centimeter. You can take either this side or this side. 10 centimeter. So from 2F it will be 20 centimeter. And here 2F2 also 20 centimeter. Now where is the object? Object is 15 centimeter. Where is 15 centimeter? Where it falls? Between what it falls? You can see the image clearly.
2F
Can
and
you see the image
2F.
clearly or you want me to draw it bigger one?
It is visible, sir.
Visible, no? You can zoom it and you can see. Now 15 centimeters from this optic center means on the left side where it is kept. From here to here it is 10. The object between 2F1 and F1, no?
Yes, sir.
Object is between 2F1 and F1. So look at the table. Don't tell anything now. We will verify that table also. The table also will come to know. If the object is between 2F1 and F1, where the image should fall, let us see with the help of this formula. Tell me what is the formula? So we have to calculate where will be the image. Formula 1 by F equal to
1 by V
1 by V minus 1 by
1 by
U.
V.
Let us substitute the values. 1 by 10 is equal to 1 by V minus into minus 1 by 15. Correct? This minus is here. This minus is here. So 1 by 10 is equal to 1 by V plus 1 by 15. Any doubts?
No, sir.
No, sir.
No,
No,
So
sir.
we'll take this to the left side. Plus 1 by 15 comes to the left side.
Minus 1 by
Minus 1 by
minus 1 by 15.
LCM
30.
30.
30. And 3s are 15 2s are. 3 minus 2 equal to 1 by 3 minus 2 is 1 by 30. V is equal to 30 centimeter. Tell me V is positive or negative?
Positive.
Positive.
Positive. If V is positive, what type of image?
real
Direct image.
Real image. Isn't it? Means it will have to go towards the right side. It has to go towards the right side. So this is a parallel which passes through F2. And at what distance the image is formed?
30 centimeter.
30 centimeters. So O to F2 is 20. Isn't it? The image is formed here. Tell me, where is the image formed?
Beyond
Beyond
2 F2.
Centimeters. This is 20. From there, 10 more centimeters. Means total 30 centimeters. The image is formed here. Where is the image?
Beyond 2
Beyond
F2.
C.
Beyond 2 F2. Correct? Beyond 2 F2. Is that right? According to the table?
yes, sir.
Yes, sir.
When the object is at 2 F1 and F1, the image is formed beyond 2 F2 only, no, according to table. Okay, let us see the magnification now. M is equal to, what is the formula?
V by U.
V by U, which is equal to V is 30, U is minus 15. So 15 ones are 15 twos are, M is equal to minus 2. M is positive or negative?
Negative.
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 Tell me if M is negative,
Virtual.
Image will be inverted.
Inverted.
right? M is
Inverted
negative, inverted image. Look at the number now. It is greater than 1 or less than 1 or equal to 1.
Greater than 1.
Greater than 1.
What do you mean by greater than 1?
Enlarged.
Magnified.
Enlarged,
Magnified.
magnified.
Enlarged. How many times it is enlarged?
2.
2 times.
Double. Get 1. M is 2. We'll ignore this minus now. Minus showed us it is inverted. Minus ಏನು ತೋರಿಸ್ತು ನಮಗೆ inverted ಇದೆ ಅಂತ ತೋರಿಸ್ತು. ಆಮೇಲೆ ನಂಬರ್ ಅಷ್ಟೇ ಹಿಡ್ಕೊಳ್ಳುತ್ತೆ ನಾವು. So M is equal to 2 means 2 by 1, which is equal to H dash divided by H. Substitute the value of H. Hence it is 2 by 1 equal to H dash divided by 2. Cross multiply. H dash is equal to 2 to the
4.
means the image will be double the size of the object. Object is 2 centimeter. Image will be
4 centimeter. 4 centimeter.
4. Is that clear to you? For ಇವು ಎರಡರ ನಡುವೆ ಬಂದಿದ್ದಕ್ಕೆಲ್ಲ ಇದೇ ರೂಲ್ ಅಂತಲ್ಲ. 30 ಬಂತು ಅದಕ್ಕೆ ನಮ್ಮ ರೂಲ್. Suppose if it is 25 means it is greater 25 ಬೇಡ 12 ಅದು ಬಂದಿತ್ತು ಅಂದ್ರೆ suppose if it is 12 the problem would have been different. See, we have drawn the diagram, we have explained the whole problem with the help of diagram. So you should also have the skill to convert the problem into the diagram. Then any type of question if they give, it will be easy for you to solve it. Any doubt in this question, please let me know.
No, sir.
So at last you do one thing. I am writing here only everything. At last you write a small sentence. One sentence ಬರೆದ್ಬಿಡಿ. ಏನಂತೆ? Therefore, the image formed is real, inverted and enlarged. How many times it is enlarged? It is double the size of the object. It's ಬರೆದ್ಬಿಡ್ರಿ. It is the conclusion part of the problem. So in the exercise you will get some more problems. Try to solve those, and if we get doubts we can discuss. Have you ever been to mobile shop to get a temper glass for your mobile phone?
Yes, sir.
Temper glass ಹಾಕಕ್ಕೆ ಹೋಗಿದ್ರಿ ಹಾಕಿಸ್ಕೊಳ್ಳಕ್ಕೆ ಹಾಕಬೇಕಲ್ಲ ಹಾಕಿಸ್ಕೊಳ್ಳಿ. You had been to the shop to get a temper glass for your mobile phone?
Yes, sir.
ಯಾವ್ಯಾವ ಆಪ್ಷನ್ ತೋರಿಸಿದ್ರು ನಿಮ್ಗೆ ಅವರು? ನಿಮ್ಮ ಮೊಬೈಲ್ ಮಾಡೆಲ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರು. ನೆಕ್ಸ್ಟ್ ದೇರ್ ವೇರ್ ಆಪ್ಷನ್ಸ್, ನೋ? ಯಾರಾದ್ರೂ ಒಬ್ರು ಹೇಳ್ತೀವಿ ನೋಡು, ನೀವು ಕರೆಕ್ಟಾಗಿ ಕೇಳಿದ್ರೆ ನಿಮ್ಗೆ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. ವಾಟ್ ವೇರ್ ದ ಆಪ್ಷನ್ಸ್ ಗಿವನ್ ಟು ಯು? ಮಾಹಿತಿ ಹಾಕ್ರಿ ಅಂತ ಹೇಳಿ ಹಾಕಿಸ್ಕೊಂಡ್ಬಂದ್ಬಿಟ್ರಿ ನೀವು. 50, 60, 70, 10 ರೂಪಾಯಿ ಕಡಿಮೆ ಇಡ್ರಿ ಅಂತೇಳಿ ತಗೊಂಡ್ಬಂದ್ಬಿಟ್ರಿ ಅಲ್ಲ. ಓಕೆ, ಒನ್ ಮೋರ್ ಕ್ವಶನ್ ಲೆಟ್ ಮಿ ಆಸ್ಕ್ ಯು. ಅದನ್ನ ಬಿಡೋಣ, ಬಿಟ್ಟು ಎನಿಬಡಿ ಆಫ್ ಯು ಆರ್ ವೇರಿಂಗ್ ಸ್ಪೆಕ್ಟಕಲ್ಸ್? ಯಾರಾದ್ರೂ ಸ್ಪೆಕ್ಟಕಲ್ಸ್ ವೇರ್ ಮಾಡ್ತೀರಿ ಇಲ್ಲಿ?
Yes, sir.
ಯಾರು? Who wears? Mega yaar?
Mega, sir.
Mega wears, sir?
Yes, sir.
Can you tell me the number of your lens, the spectacle?
0.25.
Plus or minus?
Don't know, sir.
Oh,
So only I know 0.25.
what is that 0.25? What is 0.25? Thickness, sir? Weight? ಇಲ್ಲ ಅದ್ರ ಸೈಜು? Whenever anybody in your house, it may be your parents, it may be your grandparents, your uncle, auntie, they wear the spectacles, they will give you some numbers. Have you ever experienced? ನೋಡಿದಿರಿ, ಕೇಳಿದಿರಿ?
Yes, sir.
Yes, sir.
sir. So have you ever been to an optician? Optician ಕಡೆ ಹೋಗಿದ್ರೆ ಯಾವಾಗಾದ್ರು? ಬೋರ್ಡ್ ಹಾಕಿರ್ತಾರೆ, ABCD ಏನೇನೋ ನಂಬರ್ ಹಾಕಿರ್ತಾರೆ. They will ask you to read. ಚಸ್ಮಾ ಕೊಟ್ಟಿರ್ತಾರೆ, ಅದ್ರ ಮುಂದೆ ಏನೇನೋ ಸ್ಲೈಡ್ಸ್ ಇಟ್ಟಂಗೆ ಇರ್ತಿರ್ತಾರೆ, ಸಣ್ಣ ಗ್ಲಾಸಸ್, ಲೆನ್ಸಸ್. ಈಗ ಅದು ಕಾಣಿಸುತ್ತೆ ಅಂತ ಕೇಳ್ತಾರೆ, ಈ ಕಡೆ ಕಾಣಿಸತೈತ್ರಿ, ಈ ಕಡೆ ಕಾಣಿಸ್ಕೋತೀರಿ ಅಂದ್ರೆ ಟಕ್ ಟಕ್ ಈ ಕಡೆ ಒಂದು ತೆಗಿತಾರೆ, ಇನ್ನೊಂದು ಹಾಕ್ತಾರೆ. Have you seen?
Yes, sir.
Yes, sir.
What are they checking? ಏನ್ ಚೆಕ್ ಮಾಡುತ್ತೆ? ಯಾವ ಲೆನ್ಸ್ ಹಾಕಿದ್ರೆ ನಿಮ್ಗೆ ಕಾಣಿಸುತ್ತೆ ಅದನ್ನ ಚೆಕ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಅದಕ್ಕಿಂತ ಮೊದಲು ದೇರ್ ಇಸ್ ಎ ಮಷೀನ್ ಒಳಗಡೆ ಹಿಂಗ್ ಕಣ್ಣು ಹಾಕಿಡ್ರಿ ಅಂತಾರೆ. ಫಸ್ಟ್ ಕಣ್ಣು ಹಾಕಿಟ್ಟಿರ್ತೀರಿ, ಆಮೇಲೆ ಏನೋ ಫೋಟೋ ಹೊಡೆದಂಗೆ ಕಟ್ಟನ್ನು ಕ್ಲಿಕ್ ಮಾಡ್ತಾರೆ. ವಾಟ್ ವಿಲ್ ದೇ ಡೂ ಅಟ್ ದಟ್ ಟೈಮ್? Because what we are learning in these chapters, no, whatever we are learning in the science, note electricity, magnetic effect of electric current, we did not learn only what is given in the textbook. We have applied it in our life. ನೋಡ್ರಿ, ಮೋಟರ್ ಅಂದ ತಕ್ಷಣ ನೆನಪಾಗುತ್ತೋ ಇಲ್ಲ? ಫ್ಯಾನು, ವಾಷಿಂಗ್ ಮಷಿನ್, ಇವೆಲ್ಲ ದೇ ವರ್ಕ್ ಆನ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ಆಫ್ ಸೈನ್ಸ್. Similarly, even optics, it works on the science only, which we use in our day-to-day life. Have you ever heard of this point? ಇವನ್ನೆಲ್ಲಾದ್ರೂ ನೋಡಿದಿರಿ? 2.5D ಗ್ಲಾಸ್, 4D ಗ್ಲಾಸ್, 5D ಗ್ಲಾಸ್. Ever seen?
The clarity of glass.
Clarity of glass, eh? What do you mean by clarity? Clarity means
Clarity, sir.
human eye. ಅದೇ ಹ್ಯೂಮನ್ ಐ ಕಲರ್ಫುಲ್ ವರ್ಡ್ ಬರುತ್ತಲ್ಲ, ಇವೆಲ್ಲ ಹೆಲ್ಪ್ ಆಗ್ತಾವ. ನಿಮ್ ಚಸ್ಮಾ ಹೆಂಗ್ ಬಂತು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುತ್ತೆ, ಚಸ್ಮಾ ಯಾಕೆ ಬರುತ್ತೆ ಅದನ್ನೂ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುತ್ತೆ, ಚಸ್ಮಾ ಬಂದ್ರೆ ಹೆಂಗ್ ಕರೆಕ್ಷನ್ ಮಾಡೋದು ಅದು ಮಾಡುತ್ತೆ. ಬಿಕಾಸ್ ಇಟ್ಸ್ ನಾಟ್ ಎ ಡಿಸೀಸ್ಗೆ ಟ್ರೀಟ್ಮೆಂಟ್ ಇರುತ್ತೆ. ದೀಸ್ ಆರ್ ದ ಡಿಫೆಕ್ಟ್ಸ್. ಏನಂತೀವಿ? ಡಿಫೆಕ್ಟ್ಸ್ ಅಂತೀವಿ. ಡಿಫೆಕ್ಟ್. ದಿಸ್ ಇಸ್ ನಾಟ್ ಎ ಡಿಸೀಸ್ ಆಫ್ ಗೆಟಿಂಗ್ ಎ ಸ್ಪೆಕ್ಟಾಕಲ್. ಇಟ್ ಇಸ್ ನಾಟ್ ಎ ಡಿಸೀಸ್, ಇಟ್ಸ್ ಅ ಡಿಫೆಕ್ಟ್. ಡಿಫೆಕ್ಟ್ ಕೆನಾಟ್ ಬಿ ಕ್ಯೂರ್ಡ್, ಇಟ್ ಶುಡ್ ಬಿ ಕರೆಕ್ಟೆಡ್. ಈಗ ನಿಮ್ಮ ಮನೇಲಿ ಟೇಬಲ್, ಪಾಟು, ಯಾವ್ದಾದ್ರು ಟ್ರೆಜರಿ ಇರ್ಬೋದು, ಏನಾದ್ರು ಕುಂಟಿರ್ತೈತಲ್ಲ, ನೋಡಿದಿರಿಲ್ಲ? ಅವಾಗ ಕುಂಟಿರ್ತಲ್ಲ ಒಂದ್ ಸೈಡ್ ಹಿಂಗೆ, ನೀವೇ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ಡ್ ನೋಡಿದಿರಿಲ್ಲ? ನಿಮ್ ಡೇ ಟು ಡೇ ಲೈಫ್ ಇದ್ದನು ಕ್ವಶನ್ ಕೇಳತ್ತೀನಿ, ನೀವು ಇದನ್ನಾದ್ರೂ ಆನ್ಸರ್ ಮಾಡ್ರಿ. ಕುಂಟಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಿ? ವಾಟ್ ವಿಲ್ ಯು ಡೂ?
ಸರ್, ರಟ್ ಮಾಡಿ ಚಿತ್ರ ಬುಡಕಿಡ್ತೇವ್ರಿ, ಕಾಲ್ ಬುಡಕ್.
ಅದೇ ಒಂದ್ ಸ್ವಲ್ಪ ಹಿಂಗೆ ತಗೊಂಡು ಇದನ್ನ ಮಾಡಿಸಿ ಫಸ್ಟ್ ಟೆಸ್ಟ್ ಮಾಡ್ತೀರಿ. ಇನ್ನೊಂದ್ ಸ್ವಲ್ಪ ಬೇಕಂದ್ರೆ ಇನ್ನೊಂದು ಮಾಡಿಸ್ತೀರಿ, ಇನ್ನೊಂದು ಇಡ್ತೀರಿ, ಇನ್ನೂ ಬೇಕಂದ್ರೆ ಇನ್ನೂ ಮಾಡಿಸ್ತೀರಿ, ಇನ್ನೂ ಇಡ್ತೀರಿ. ಯು ಆರ್ ಕರೆಕ್ಟಿಂಗ್ ದ ಲೆಗ್. ಬಟ್ ಯು ಆರ್ ನಾಟ್ ಟ್ರೀಟಿಂಗ್ ದ ಲೆಗ್. ಅದನ್ನ ತೆಗೆದು ಬಿಟ್ರೆ ಏನಾಯ್ತು, ಮತ್ತೆ ಡಿಫೆಕ್ಟ್ ಹಂಗೆ ಇರ್ತೈತಲ್ಲ. ಸೊ ಸ್ಪೆಕ್ಟಾಕಲ್ಸು ಹಂಗೆ ಹಾಕೊಂಡಾಗ ಏನ್ ಕಣ್ ರಿಪೇರಿ ಆಗಲ್ಲ, ಅದಕ್ಕೆ ಹಾಕೊಂಡಾಗ ಅಷ್ಟೇ ಚಂದ ಕಾಣೋದು, ತೆಗೆದ್ರೆ ಮತ್ತದೇ ಗೊತ್ತಾಯ್ತಲ್ಲ. ಸೊ ವಾಟ್ ಆರ್ ದೀಸ್ 2.5D? ಅವರ್ ಮೊಬೈಲ್ ಫೋನ್ಸ್, ನಮ್ಮ ಮೊಬೈಲ್ ಫೋನ್ಸ್ ಏನ್ ಬಂದಾವಲ್ಲ ಡಿಸ್ಪ್ಲೇ, ಮೆನಿ ಆಫ್ ದಮ್ ಡಿಸ್ಪ್ಲೇ ಕಂಟೆಂಟ್ಸ್ 2.5D or 1.5D ಗ್ಲಾಸ್. 1.5D ಗ್ಲಾಸು ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರೋದು. ಏನ್ ಡಿ ಅಂದ್ರೆ ಏನಿದು? ಡಸ್ ಇಟ್ ಬಿಲಾಂಗ್ ಟು ದ ಡೈಮೆನ್ಷನ್? Is it dimension? No, it is not the dimension. It is called the power of lens. What is power of lens? Power of lens andre ನಾನು ಇಲ್ಲೊಂದಷ್ಟು ಡಯಾಗ್ರಾಮ್ ತೆಗಿತೀನಿ. I will draw the diagram. You have to tell me whose focal length is more. Whose focal length is more? Tell me first and second. Whose focal length is more? First or second? ಕನ್ಸತ್ತಿತ್ತಲ್ಲ ದೊಡ್ಡ ತೆಗಿ.
First.
First, sir.
So this is the first lens. This is the second lens. Whose focal length is more in these two?
First, sir.
First, many are telling first. Okay, boys ಕಡೆಯಿಂದ ಆನ್ಸರ್ ಬಂದಿಲ್ಲ ನನಗೆ. ಫೋಕಲ್ ಲೆಂತ್ ಈಗೇನು ಮಿಸ್ಟೇಕ್ ಆದ್ರೂ ಏನು ಸಮಸ್ಯೆ ಇಲ್ಲ, ಹೇಳ್ರಿ, ನಿಮಗೆ ತಿಳಿಸಿ ಹೇಳ್ತೀನಿ ನಾನು ಏನು. ಬಾಯ್ಸ್, ನವೀನ್, ದರ್ಶನ್, first only. You also choose first only. Tell the focal length of the first. Who told second? ಯಾರದು?
ವಿಶ್ವರಾಜ್ ಸರ್.
Vishwaraj, you think the focal length of second is more. Why did you feel the second is more? ಹಂಗೆ ಗೆಸ್ ಮಾಡಿದನೋ ಹೆಂಗೆ ಗೆಸ್ ಮಾಡಿದೆ?
ಸರ್ ಲೆಂತ್ ಐತ್ರಿ ಸರ್.
ಲೆಂತ್ ಎರಡೂ ಸೇಮ್ ಅದಾವಲ್ಲ ನೋಡಿ, ಇದು ಅಷ್ಟೇ ಇದು ಅಷ್ಟೇ. ನಾವು ಲೆಂತ್ ಹೇಳತ್ತೀನಿ, ನಾನು ಫೋಕಲ್ ಲೆಂತ್ ಹೇಳ್ತೀನಿ. ಓಕೆ, ಕಮಿಂಗ್ ಟು ದ ಪಾಯಿಂಟ್. ಓಕೆ, ಸೊ ವೇರ್ he told the second one. Now the question comes, what is focal length? Focal length ಅಂದ್ರೆ ಏನು? ಯಾರಿಗೂ ಗೊತ್ತಿಲ್ಲ? What is focal length? Distance between the principal focus and optic center, correct? Navida, distance between the principal focus and optic center. Andre principal focus means where the image is formed. When the object is at infinite distance, the image is formed at principal focus. That point we consider as principal focus. Our principal focus in the optic center ವರೆಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿದೆ ಅದನ್ನ ಫೋಕಲ್ ಲೆಂತ್ ಅಂತೀವಿ. ಓಕೆ, ಎದ್ರ ದೊಡ್ಡದು ಅಂತ ಕೇಳಿದ್ ನಾವು. ಸಪೋಸ್ ಐ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಎ ಸರ್ಕಲ್ ಫಾರ್ ದಿಸ್. ಯಾವ ತರ ರೇಡಿಯಸ್ ದೊಡ್ಡದಿದೆ ಸರ್? ಫಸ್ಟ್ ಆರ್ ಸೆಕೆಂಡ್?
Second.
ಸೆಕೆಂಡ್ ದ ರೇಡಿಯಸ್ ಇಸ್ ಮೋರ್. ನೋಡ್ರಿ ಎಷ್ಟು ಫ್ಲಾಟ್ ಹಾಕೊಂತ ಹೋಗ್ತಿತ್ತಲ್ಲ ಲೆನ್ಸು, ಫೋಕಲ್ ಲೆಂತ್ ಅಷ್ಟೇ ಜಾಸ್ತಿ ಹಾಕೊಂತ. ಹೌ ಮಚ್ ಇಟ್ ಫ್ಲಾಟನ್ಸ್, ಫೋಕಲ್ ಲೆಂತ್ ಇನ್ಕ್ರೀಸಸ್. ಹೌ ಮಚ್ ಇಟ್ ಬಲ್ಜಸ್, ಫೋಕಲ್ ಲೆಂತ್ ರಿಡ್ಯೂಸಸ್. ನೋಡ್ರಿ ಈಗೆಲ್ಲ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಎ ಲೆನ್ಸ್, ಇಷ್ಟು ಬಲ್ಜ್ ಆಗಿದೆ. ಇದನ್ನ ಸರ್ಕಲ್ ತೆಗೆಯಕ್ಕೆ ಹೋದ್ನಿ ಅಂದ್ರೆ ಸರ್ಕಲ್ ವಿಲ್ ಬಿ ವೆರಿ ಸ್ಮಾಲ್. ನೋ, ಸರ್ಕಲ್ ವಿಲ್ ಬಿ ವೆರಿ ಸ್ಮಾಲ್. ಹಿಯರ್ ಆಲ್ಸೋ ದ ಸರ್ಕಲ್ ಇಸ್ ವೆರಿ ಸ್ಮಾಲ್. ನಿನ್ನೆ ಇದನ್ನ ತೆಗೆದು ತೋರಿಸಿದ್ನಲ್ಲ ನಿಮ್ಗೆ, ಹೌ ಟು ಡ್ರಾ ಎ ಲೆನ್ಸ್ ಅಂದಾಗ ಎರಡು ಸರ್ಕಲ್ ತೆಗೆದು ನಡುವೆ ಲೆನ್ಸ್ ಇರುತ್ತೆ. ಈಗ ಹೇಳ್ರಿ, ರೇಡಿಯಸ್ ಇಟ್ ಈಸ್ ಸ್ಮಾಲರ್. Just now as you told, if radius is smaller, focal length is bigger. ಇನ್ನೊಂದೇನು ರಿಲೇಷನ್ ಬರ್ದಿದ್ರೆ r is equal to
2f.
2f.
ಮತ್ತೆ if radius is smaller, focal length is bigger or smaller?
Smaller.
Suppose ಇಲ್ಲಿ r is equal to, ಇಲ್ಲಿ 4 ಇದ್ರೆ ಇಲ್ಲಿ r is equal to 10 ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. f ಹೇಳ್ರಿ ಇಲ್ಲಿ ಎಷ್ಟಿರುತ್ತೆ? Half of radius.
2,
ಇಲ್ಲಿ ಎಷ್ಟು F ಎಷ್ಟು?
5.
5.
5,
So did you learn something now? If the lens is bulged, focal length is
Decreased.
ಡಿಗ್ರೀಸ್
decreased. Andre smaller value. If the focal length is smaller value, image is formed near to the optic center. So ಇದನ್ನ ರೇ ತೆಗೆದು ಬಿಟ್ರೆ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಸಪೋಸ್ ಇಫ್ ಐ ಡ್ರಾ ಆಫ್ ದಿಸ್, ಈ ಲೆನ್ಸ್ ತೆಗೆದ್ರೆ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ಎದ್ರಾಗ ಸಮೀಪ ಇದೆ ಇಮೇಜ್. Principal focus is near to which? In the first diagram or in the second diagram?
In first diagram. First diagram.
Is that clear? If the lens is bulged, therefore the focal length is smaller, therefore the image is formed near to the optic center. Optic center nearby. Isn't it? So these are the power of the lenses. So how do we define the power of the lenses? Every power, other thickness prakara power change. Magnification. Have you seen the magnifying glass? Magnifying glass nodri? Have you seen?
ಎಸ್ ಸರ್ ಎಸ್
Magnifying glass, how much thicker it is, ಎಷ್ಟು ದಪ್ಪ ಇರುತ್ತಲ್ಲ ಅಷ್ಟು ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. Do you agree? ಎಷ್ಟು ದಪ್ಪ ಇರುತ್ತೆ ಗ್ಲಾಸು ಅಷ್ಟೇ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಜಾಸ್ತಿ. ಎಷ್ಟು ತೆಳ್ಳಗೆ ಇರುತ್ತೆ ಅಷ್ಟು ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಕಡಿಮೆ. ಹೌದಲ್ಲ? ಈಗ ದಪ್ಪ ಇದ್ದಾಗ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಜಾಸ್ತಿ, ಆದ್ರೆ ದಪ್ಪ ಇದ್ದಾಗ ಫೋಕಲ್ ಲೆಂತ್ ಕಡಿಮೆ. ಪವರ್ ಜಾಸ್ತಿ, ಫೋಕಲ್ ಲೆಂತ್ ಕಡಿಮೆ. ತೆಳ್ಳಗೆ ಇದ್ದಾಗ ಫೋಕಲ್ ಲೆಂತ್ ಜಾಸ್ತಿ, ಪವರ್ ಕಡಿಮೆ. Do you think these two are directly proportional or inversely proportional? Focal length increase ಆದಂಗೆ ಪವರ್ ಜಾಸ್ತಿ ಆಗ್ತಿತ್ತೋ ಕಡಿಮೆ ಆಗ್ತಿತ್ತೋ? ಲಾಜಿಕಲಿ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಬಿಟ್ರಿ. ಹೌದಲ್ಲ? ಫೋಕಲ್ ಲೆಂತ್ ಜಾಸ್ತಿ ಹಾಕೊಂತ ಹೋಯ್ತಂದ್ರೆ ಲೆನ್ಸ್ ಥಿನ್ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ. Isn't it? At least you understood this. If the focal length increases, the lens becomes thin. If it becomes thin, the power becomes less. So we tell that power is the reciprocal of focal length. Power of a lens is reciprocal of focal length divided by everything. In the focal length denominator ಎಷ್ಟು ನಂಬರ್ ಜಾಸ್ತಿ ಆಗ್ತೈತಲ್ಲ ಪವರ್ ಅಷ್ಟೇ ಕಡಿಮೆ. Tell me, 1/10 is bigger or 1/100 is bigger?
1/10.
1/10.
Say 10 is bigger or 100 is bigger?
10.
100 is bigger.
Right.
100 is bigger. So focal length 100 andre focal length 100 means, don't you think the focal length means it is thinner? Focal length ಜಾಸ್ತಿ ಇದ್ರೆ thin ಆದ್ರೆ ಏನಾಯ್ತು? Value is reduced. 1/10 is greater than 1/100. The power of this lens is greater than power of this lens. Logic ಅರ್ಥ ಆಯ್ತು?
Yes, sir.
Yes,
ಎಸ್
sir.
ಸರ್
Yes,
The
sir.
principle, the focal length increases, the lens becomes thin. As the lens becomes thin, the power decreases. Therefore, the power of the lens is given by the formula 1/f. 1/f ಅಂತ ಕೊಡ್ತೀವಿ. And the SI unit ಬೇಕಲ್ಲ, ಈಗ d ಅನ್ನತ್ತಿದ್ವಿ ಆಗಲಿಲ್ಲ. The SI unit is ಓದ್ರಿ
Diopter.
diopter. The SI unit of power of lens is diopter. Got it? By this we will understand the focal length of the lens. ಇದರ ಮೇಲೆ MCQ question ಕೊಟ್ಟಿದ್ರು. What was the question? The focal length of two lenses are f1 is equal to 20 centimeter, f2 is equal to 15 centimeter. Find the power of both the lenses. Simple question. And write which is greater. Find which has more power. So hang ಮಾಡ್ತೀರಿ ಇಲ್ಲಿ. So P1 is equal to 1/20, correct?
Yes,
Yes, sir.
Yes, sir.
P2 is equal to
1/15.
1/15.
which is equal to relation ಬಂತು 0.
0.05.
0.05.
Diopter.
Diopter.
Diopter. Okay, here P2 is equal to 0.06. It doesn't stop actually. It doesn't have a terminating decimal. It has infinite decimal expansion. So approximately, tell me, ನೋಡ್ರಿ ಇವೆರಡು ನೋಡಿದ್ರೆ ಏನ್ ಅನ್ಸುತ್ತೆ ಯಾವ್ದು ದೊಡ್ಡದಾಯ್ತು? P1 is greater or P2 is greater?
0.05.
P2.
0.05 is bigger than 0.06. Are you sure?
No, sir.
0.06 is bigger.
The power of the second lens is greater than the power of the first lens. So E type applied questions ಕೊಡೋ chances ಇರುತ್ತೆ. So you should be ready. Concept clarity ಇದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. Concept clarity ಅಂದ್ರೆ ಏನು? F ಎಷ್ಟು ದೊಡ್ಡದಿರುತ್ತೆ ಪವರ್ ಅಷ್ಟೇ ಕಡಿಮೆ ಇರುತ್ತೆ. F ಎಷ್ಟು ಸಣ್ಣದಿರುತ್ತೆ ಪವರ್ ಅಷ್ಟೇ ದೊಡ್ಡದು. ಕ್ಲಿಯರ್ ಆಯ್ತು ಕಾನ್ಸೆಪ್ಟ್? ಆನ್ ದಿಸ್ ಪವರ್ ಅದೇ ಎಷ್ಟು ಥಿಕ್ನೆಸ್ ಬರಬೇಕಲ್ಲ ನಿಮ್ ಕಣ್ಮುಂದೆ ಚಶ್ಮಾ 40 ಹಾಕೋತಿರಲ್ಲ. ಮೊದ್ಲ ಹೆಸರಿತ್ತು ಅದಕ್ಕೆ 40 ಅಂತಿದ್ರು. 40 ಅಂದ್ರೇನು? 40 ನಂತರ ಬರ್ತಿತ್ತು ಅದು. 40 ಅಂದ್ರೆ ಎಷ್ಟು ಇದೆ?
40.
40 40 ವಯಸ್ಸು ಆದ್ಮೇಲೆ ಚಶ್ಮಾ ಬರ್ತಿತ್ತು ಜನರಿಗೆ ಮೊದ್ಲ. ಇವತ್ತು ನೋಡ ಮೇಘ ಎಷ್ಟು ನಿನಗೆ? 15?
Yes, sir. Sir, it is just for headache.
ನಂಬರ್ ಹೇಳಿದಿಲ್ಲೋ, ಜಸ್ಟ್ ಫಾರ್ ಹೆಡೇಕ್ ಇಲ್ಲ.
Sir, ಅಷ್ಟ headache ಇದೆ.
ನಾನೇನ್ ಹೇಳತ್ತೀನಿ ನಿನಗೆ, ಹೆಡೇಕ್ ಯಾಕೆ ಬಂತು ಗೊತ್ತು? ಯಾಕೆ ಬಂದಿಲ್ಲ?
ಗೊತ್ತ್ರಿ.
ಕಣ್ಣಿನ ಡಿಫೆಕ್ಟ್ ಆಗಿರುತ್ತೆ. ಕಣ್ಣು ಡಿಫೆಕ್ಟ್ ಆದ್ರೆ ಫೋಕಲ್ ಲೆಂತ್ ಅಡ್ಜಸ್ಟ್ಮೆಂಟ್ ಇರಂಗಿಲ್ಲ. ವಿ ಹ್ಯಾವ್ 2 lenses ಇನ್ ಅವರ್ ಐಸ್. ಇಲ್ಲಿ ಮುಂದೊಂದು ಲೆನ್ಸ್ ಇನ್ನೊಂದು ಲೆನ್ಸ್ ಇದೆ. ಆ ಲೆನ್ಸ್ ಇಂದ ನಾಟ್ 2 ಲೆನ್ಸ್ 1 ಲೆನ್ಸ್ ಇದೆ, ಅದು ಹಿಂಗಾಗ್ತಾ ಇರುತ್ತೆ. ವಿ ಹ್ಯಾವ್ 1 ಲೆನ್ಸ್, ಸಮಟೈಮ್ಸ್ ಬಲ್ಜ್ಡ್, ಸಮಟೈಮ್ಸ್ ಬಲ್ಜ್ ಇರುತ್ತೆ, ಸಮಟೈಮ್ಸ್ ಬಲ್ಜ್ಡ್ ಇನ್ ಆಗುತ್ತೆ. ಬಲ್ಜ್ಡ್ ಔಟ್, ಬಲ್ಜ್ಡ್ ಇನ್. ನಮ್ಮ ಒಳಗೆ ಒಂದು ಲೆನ್ಸ್ ಇದೆ. ದಿಸ್ ಲೆನ್ಸ್ ಡಸ್ ಆಲ್ ದಿಸ್ ವರ್ಕ್. ನಾವು ಸಮೀಪ ಹಿಂಗ ನೋಡ್ತೀವಲ್ಲ, ವೆರಿ ನಿಯರ್ ಮೊಬೈಲ್ ಹಿಂಗೆ ಹಿಡ್ಕೊಂಡು ಕೂತಿರ್ತೀವಿ, ಕಣ್ಣಿಗೆ ಹಚ್ಕೊಂಡು ಹಿಂಗೆ ಹಿಡ್ಕೊಂಡು ಕುಂತು ಹಿಂಗೆ ನೋಡ್ತಿರ್ತೀವಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ? ದ ಲೆನ್ಸ್ ಬಿಕಮ್ಸ್ ಬಲ್ಜ್ಡ್. ಯಾಕೆ? ಸಮೀಪ ಬಂದಾಗ ಮ್ಯಾಗ್ನಿಫೈ ಜಾಸ್ತಿ ಆಗ್ಬೇಕಲ್ಲ. ಮ್ಯಾಗ್ನಿಫೈ ಜಾಸ್ತಿ ಅಂದ್ರೆ ಪವರ್ ಜಾಸ್ತಿ ಬೇಕು. ಪವರ್ ಜಾಸ್ತಿ ಅಂದ್ರೆ ಫೋಕಲ್ ಲೆಂತ್ ಕಡಿಮೆ ಮಾಡ್ಬೇಕು. ಇದು ಫೋಕಲ್ ಲೆಂತ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಹಿಂಗೆ ಕುಂತು ಬಿಡ್ತೀವಿ. ಬಹಳತನ ನೋಡಿ ಏನಾಗುತ್ತೆ? ಇಟ್ ವಿಲ್ ನಾಟ್ ಚೇಂಜ್. ಹಿಂಗ್ ಹೋಗಿ ಹಿಂಗ್ ಆಗ್ಬೇಕಿದೆ. ಆಕ್ಚುಲಿ ದೂರಿಂದ ನೋಡ್ಬೇಕಾದ್ರೆ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಕಮ್ ಟು ದಿಸ್ ಶೇಪ್ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಸಿ ಫಾರ್. ಎರಡು ಒಂದೇ ಸಲ ಆಗೋದಿಲ್ಲ. ದೂರಿಂದ ಸಮೀಪದಿಂದ ಎರಡು ಒಂದೇ ಸಲ ನೋಡಕ್ ಸಾಧ್ಯನೇ ಇಲ್ಲ ನೀವು. ಕೆನ್ ಯು ಸಿ? ಟ್ರೈ ಯುವರ್ ಸೆಲ್ಫ್. ಒಂದ್ ಕೈ ಸಮೀಪ ಹಿಡ್ಕೊಳ್ರಿ, ಒಂದ್ ಕೈ ದೂರ ಹಿಡ್ಕೊಳ್ರಿ, ಯಾವ್ದಾದ್ರು ಒಂದ್ ಕೈ ನೋಡ್ರಿ. ಟ್ರೈ ವಿತ್ ದಿಸ್. ಟ್ರೈ ಮೊಬೈಲ್ ಕೆಳಗಿಡ್ರಿ, ಟ್ರೈ ಮಾಡ್ರಿ ನೋಡೋಣ. ಒಂದ್ ಸಮೀಪ ಹಿಡ್ಕೊಳ್ರಿ, ಒಂದ್ ದೂರ ಹಿಡ್ಕೊಳ್ರಿ. ಟ್ರೈ ಟು ಲುಕ್ ಎಟ್ ಯುವರ್ ನಿಯರ್ ಹ್ಯಾಂಡ್. Can you see the other hand clearly?
No, sir.
No, sir.
Now
No,
look at
sir.
the other hand which is far. Look at that. Can you see this hand clearly?
No, sir.
No, sir.
These two changes you can see. ದೂರಿಂದ ನೋಡ್ಬೇಕಾದ್ರೆ ಇದು ಬೇಕು ನಮ್ಗೆ, ಹಿಂಗಾಗ್ಬೇಕು ಲೆನ್ಸ್. ನೋಡ್ಬೇಕಾದ್ರೆ ಫ್ಲಾಟ್ ಆಗಿಬಿಡ್ತದೆ ಆಟೋಮೆಟಿಕ್. ಅಲ್ಲಿ ಒಳಗಡೆ ವಿ ಹ್ಯಾವ್ ಮಸಲ್ಸ್. ಮಸಲ್ ಹಿಂಗ್ ಜಗ್ಗಿ ಬಿಡ್ತಾವ. ಜಗ್ಗಿದಾಗ ಏನಾಗುತ್ತೆ? ಫ್ಲಾಟ್ ಆಗುತ್ತೆ. ಸಮೀಪ ಬರ್ಬೇಕಾದ್ರೆ ಲೂಸ್ ಮಾಡುತ್ತೆ. ಲೂಸ್ ಮಾಡಿದ ತಕ್ಷಣ ದಪ್ಪ ಆಗುತ್ತೆ. ಇಟ್ ಈಸ್ ಆಲ್ ಹ್ಯಾಪನಿಂಗ್ ಇನ್ ಅವರ್ ಐಸ್, ಕಣ್ಣೊಳಗಡೆ. ಇಟ್ ಈಸ್ ದ ನೇಚರ್. ನೋಡ್ರಿ ದೃಷ್ಟಿ ಹೆಂಗ್ ಕೊಟ್ಬಿಟ್ಟಿದೆ ನಮ್ಗೆ. ನೇಚರ್ ಹ್ಯಾಸ್ ಗಿವನ್ ಅಸ್. ಸೊ ಯು ನೋ ವಿ ಟೆಲ್ ಇಟ್ ಈಸ್ ಅ ಬೈನಾಕ್ಯುಲರ್ ವಿಷನ್. ಬೈನಾಕ್ಯುಲರ್ ಅಂದ್ರೆ ವಿ ಕ್ಯಾನ್ ಸಿ ನಿಯರ್ ಬೈ ಥಿಂಗ್ಸ್, ವಿ ಕ್ಯಾನ್ ಸಿ ಫಾರ್ ಥಿಂಗ್ಸ್ ಆಲ್ಸೋ. ಬಟ್ ಸಮ್ ಆಫ್ ದ ಅನಿಮಲ್ಸ್ ಕೆನಾಟ್ ಸಿ ಲೈಕ್ ದಿಸ್. Some of the animals have lot more capacity than us. ನಮ್ಗಿಂತ ಹೆಚ್ಚಿಗೆ ಕೆಪಾಸಿಟಿನೂ ಇದೆ. ನಮ್ಗೊಂದು ಸ್ವಲ್ಪ ಲೈಟ್ ಆಫ್ ಮಾಡಿಬಿಟ್ರೆ ಏನೂ ಕಾಣಿಸಲ್ಲ. ಬಟ್ ಕ್ಯಾಟ್, ಡಾಗ್, ದೇ ಕ್ಯಾನ್ ಸಿ ಇವನ್ ಇನ್ ಡಾರ್ಕ್ನೆಸ್. ಇಷ್ಟು ಲೈಟ್ ಬಂದ್ರೆ ಸಾಕು ಕಾಣಿಸುತ್ತೆ. ನಮಗೆ ಜಾಸ್ತಿ ಲುಮಿನಸ್ ಬೇಕು ಅಂದಾಗ ಕಾಣಿಸುತ್ತೆ. isn't it? ಯಾರು ಕತ್ಲಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಾರೆ, ಯಾರು ಫುಲ್ ಬ್ರೈಟ್ ಅಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಾರೆ, ಅವ್ರದ್ದು ಕಣ್ಣಲ್ಲಿ ಡಿಫೆಕ್ಟ್ ಹುಟ್ಟುತ್ತೆ. ಆ ಡಿಫೆಕ್ಟ್ ಕರೆಕ್ಟ್ ಮಾಡಕ್ಕೆ ಲೆನ್ಸ್ ಬರ್ತಾರೆ, ಚಶ್ಮಾ. ಇವಕ್ಕೂ ಲೆನ್ಸ್ ಅಂತೀವಿ. ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಲೆನ್ಸ್. ವಾಟ್ ಯುವರ್ ಕ್ಯಾಮ್ರಾಸ್ ಆರ್ ಮೇಡ್ ಅಪ್ ಆಫ್. ಕ್ಯಾಮ್ರಾ ಹಿಂದೇನಿರುತ್ತೆ?
Lens.
Lens.
Lens. Have you seen camera ಮೇಲೆ ನೀವು ಯಾವುದಾದ್ರು ಒಂದು ಮೊಬೈಲ್ ಇದನ್ನ ತೆಗೀರಿ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ they will say about the lens 2.5 f ಅಂತಾರೆ. Have you seen this? ನೋಡಿದಿರಿ? ಇವತ್ತು ತೆಗೆದು ನೋಡ್ಕೊಳ್ರಿ ಸ್ವಲ್ಪ. There are different cameras. ಈಗ ಒಂದಲ್ಲ ಎರಡು ಮೂರು ನಾಲ್ಕು ಕ್ಯಾಮ್ರಾ ಬಂದವೆ. Every camera has got its own capacity ability. EF ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. Some can take very nearby photos because they will have less focal length. ಸಮೀಪಿನ ಫೋಟೋ ತೆಗೆಯಕ್ಕೆ ಲೆಸ್ ಫೋಕಲ್ ಲೆಂತ್ ಬೇಕು, ದೂರಿನ ತೆಗೆಯಕ್ಕೆ ಲಾರ್ಜ್ ಫೋಕಲ್ ಲೆಂತ್ ಬೇಕು. ಅಂಡರ್ಸ್ಟುಡ್? ಕೇಳಿಸ್ತಾ ಇದೆಯಲ್ಲ? ನೋಡ್ರಿ, ಇದು ಆಪ್ಟಿಕ್ಸ್ ಬ್ರಾಂಚ್ ಇಂದ ಎಷ್ಟೆಲ್ಲ ಡೆವಲಪ್ಮೆಂಟ್ ಆಗಿದೆ ಟೆಕ್ನಾಲಜಿ. ಲಾಟ್ ಆಫ್ ಟೆಕ್ನಾಲಜಿಕಲ್ improvement with the help of our science. Any doubts in the power of the lens? What is the formula to calculate power? P is equal to 1 by
F.
What happens if F increases?
Power decreases.
Power will become less.
F increases means the lens becomes thinner or bulgier?
Bulger.
Thinner.
ಬಲ್ಜ್ ಆಯ್ತಂದ್ರೆ ಫೋಕಲ್ ಲೆಂತ್ ಸಣ್ಣದ ಹಾಕೊಂತ ಹೋಗ್ತೈತಿ. ನೋಡ್ರಿ ಇಷ್ಟಿರ್ತೈತಿ, ಹಿಂಗ ಬಲ್ಜ್ ಹಾಕೊಂತ ಹೋಯ್ತಂದ್ರೆ ಫೋಕಲ್ ಲೆಂತ್ ಅಲ್ಲಿದ್ದಿದ್ದು ಇಲ್ಲಿಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. ಸೊ ಫೋಕಲ್ ಲೆಂತ್ increases, the lens becomes thinner. So when the lens becomes thinner, the power reduces. You understood the link between all these concepts?
Yes, sir.
Any doubts? Any doubts in the power of the cell? So SI unit of this is diopter. It is denoted by the letter D. Capital D ಹಾಕಬೇಕಿಲ್ಲ, ಅಗಲ್ D ಹಾಕಿದ್ದಲ್ಲ ಅಲ್ಲಿ. It is capital D, upper case D. ಮತ್ತೆ ನೋಡ್ತೀನಿ ಸರ್ಚ್ ಬುಕ್. Okay, so when you go to the focal length, ಇದು ಹೇಳ್ರಿ ನನಗೆ F ನೆಗೆಟಿವ್, F ಪಾಸಿಟಿವ್. F ಪಾಸಿಟಿವ್ ಯಾವ ಲೆನ್ಸ್ ಇಂದಿತ್ತು?
Convex.
F negative?
Concave.
So next, ask your friends, ask your family, ask your parents. If you get the paper ಸಿಕ್ಕರೆ ನೋಡ್ರಿ, ಅವ್ರ ಸ್ಪೆಕ್ಟ್ ಹಾಕ್ತಿರ್ತಾರಲ್ಲ, ಟೋಟಲ್ ಪವರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನ್ ಮಾಡ್ತಾರೆ, ಒಂದೊಂದೇ ಲೆನ್ಸ್ ಹಾಕೊಂತ ಹೋಗ್ತಾರೆ. ಸೊ ದೇ ವಿಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿಸ್ ಪವರ್ 1 ಪ್ಲಸ್ ಪವರ್ 2 ಪ್ಲಸ್ ಪವರ್ 3 ಎಷ್ಟು ಲೆನ್ಸ್ ಹಾಕ್ತಾರೆ ಅವನ್ನೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ದ ಪವರ್ ಹೇಳ್ತಾರೆ. ಸಮೀಪಿತ ಕಾಣಿಸಲ್ಲ ಅಂದ್ರೆ ಬೇರೆ ಲೆನ್ಸು, ದೂರದ ಕಾಣಿಸಲ್ಲ ಅಂದ್ರೆ ಬೇರೆ. ಸಮೀಪದ ಕಾಣಿಸ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಕೊಡ್ತಾರೆ ನಿಮ್ಗೆ ಸ್ಪೆಕ್ಟಾಕಲ್, ದೂರಿಂದ ಕಾಣಿಸ್ಲಿಲ್ಲ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಕೊಡ್ತಾರೆ. ಗೊತ್ತಾಯ್ತಲ್ಲ? ಬಹಳಷ್ಟು ಜನ ಏನ್ ತಪ್ಪು ತಿಳ್ಕೊಂಡ್ಬಿಟ್ಟಾರೆ ಹೇಳ್ರಿ. ವಾಟ್ ಇಸ್ ಯುವರ್ ನಂಬರ್ ಅಂದ್ರೆ ಕೇಳಿದೀನಿ ನಾನು ಬಹಳಷ್ಟು ಜನ ಕೇಳಿ, ವಾಟ್ ಇಸ್ ಯುವರ್ ನಂಬರ್ ಸರ್? ಓನ್ಲಿ -0.5 ಅಂತ. ಮೈನಸ್ ಅಂದ್ರೆ ಸಣ್ಣ ನಂಬರ್ ಅಂತ ತಿಳ್ಕೊಂಡ್ಬಿಟ್ಟಿರೋದು. ಇಟ್ ಇಸ್ ನಾಟ್ ಎ ಸ್ಮಾಲ್ ನಂಬರ್. ಮೈನಸ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ವಾಟ್ ಇಟ್ ಈಸ್?
Concave.
ಮೈನಸ್ ಅಂದ್ರೆ. ಪ್ಲಸ್ ಅಂದ್ರೆ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್. ತಪ್ಪು ತಿಳ್ಕೊಬೇಡ್ರಿ. ನೆಗೆಟಿವ್ ಅಂದ್ರೆ ಸಣ್ಣ ನಂಬರ್ ಐತ್ ನಂದು ತಿಳ್ಕೊಬೇಡ್ರಿ ನೀವು, ಅದು ನಂಬರ್. ಪ್ಲಸ್ ಇದ್ರು ನಂಬರೇ, ಮೈನಸ್ ಇದ್ರು ನಂಬರೇ. ಡಿಫ್ರೆನ್ಸ್ ಇಸ್ ಪ್ಲಸ್ ಇದ್ರೆ ಸಮೀಪದ ಕಾಣಿಸಲ್ಲ ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ, ಮೈನಸ್ ಅಂದ್ರೆ ದೂರದ ಕಾಣಿಸಲ್ಲ ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಅವೆಲ್ಲ ಇನ್ ಡೀಟೇಲ್ ಆಗಿ ಆ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಕಲಿತೀರಿ ಇನ್ ದ ಹ್ಯೂಮನ್ ಐ ಅಂಡ್ ಕಲರ್ಫುಲ್ ವರ್ಲ್ಡ್. ಟಿಲ್ ದೆನ್ ಡು ನಾಟ್ ಫರ್ಗೆಟ್ ದಿಸ್, ಡು ನಾಟ್ forget the concepts of power, because power also little bit it helps there. So anything is left? Okay, so with the help of this we shall write the uses. El bardiri, uses bardilla, uses of lens. First, where all the lens are used to make the spectacles. Second, to make the contact lenses. Contact lens ಅಂದ್ರೆ ಗೊತ್ತಲ್ಲ, contact, they will be in touch with you. ಕಣ್ಣಿಗೆ ಹಾಕೋತಾರಲ್ಲ ತಗೊಂಡು, they are called as contact lens. Then microorganism
Camera.
ಕ್ಯಾಮರಾ. ಮೈಕ್ರೋಆರ್ಗಾನಿಸಮ್ ಇದರಲ್ಲಿ ನೋಡ್ತೀರಿ.
Microscope.
Microscope.
ಯಾರು ಸ್ಟೆಥೋಸ್ಕೋಪ್ ಅಂದವರು? ಸ್ಟೆಥೋಸ್ಕೋಪ್ ಅಂದವ್ರು ಯಾರು ಹೇಳಿ? ಫಸ್ಟ್ who told stethoscope? ಸ್ಟೆಥೋಸ್ಕೋಪ್ ಕಣ್ಣಿಗೆ ಹಾಕುತ್ತಿರೋ ಕಿವಿಗೆ ಹಾಕುತ್ತಿರೋ? ಟೋಟಲ್ ಯಾವುದೇ ಟೆಲಿಸ್ಕೋಪ್ ಇರಲಿ ಅದ್ರೊಳಗೆ ಲೆನ್ಸ್ ಇರ್ತಾರೆ. ದೇರ್ ಆರ್ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಟೆಲಿಸ್ಕೋಪ್ ಆಲ್ಸೋ, ವೇರ್ ದೇ ಯೂಸ್ ಮಿರರ್ಸ್, ಕಾನ್ಕೇವ್ ಮಿರರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಮಲ್ಟಿಪಲ್ ಮಿರರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಮಲ್ಟಿಪಲ್ ಲೆನ್ಸಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಎಲ್ಲಿ ಕನ್ವರ್ಜ್ ಆಗ್ಬೇಕಾಗಿರ್ತಾರೆ ರೇಸ್ ಅಲ್ಲಿ ಕಾನ್ವೆಕ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಎಲ್ಲಿ ಡೈವರ್ಜ್ ಆಗ್ಬೇಕಾಗಿರುತ್ತೆ ಲೆನ್ಸು ಅಲ್ಲಿ ಕಾನ್ಕೇವ್ ಯೂಸ್. ಮತ್ತೆ ಹೇಳ್ರಿ, ಮತ್ತೆಲ್ಲಿ ದ ಕ್ಯಾಮರಾ, ಮೊಬೈಲ್ ಫೋನ್ಸ್, projector, very good, they are used in the projectors. So these are the different uses of the lenses. ಯಾವುದೇ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಮಟೀರಿಯಲ್ ಇರಲಿ, if it is curved, it is a lens. ನಿಮ್ ಹೆಡ್ಲೈಟ್ ನೋಡಿದ್ರಿಲ್ಲ, ವೆಹಿಕಲ್ ಹೆಡ್ಲೈಟ್ ಹಿಂಗ ಕರ್ವ್ ಇರ್ತವೆ.
Yes, sir.
ಕಾರ್ ಹೆಡ್ಲೈಟ್ಸ್, ಟ್ರಕ್ ಹೆಡ್ಲೈಟ್ಸ್ ಕರ್ವ್ ವಿತ್ ಅಂತ ತಿಳ್ಕೊಡ್ರಿ, ಲೆನ್ಸ್ ಅದು ಲೆನ್ಸ್, ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಲೆನ್ಸ್. Got it? Understood? Any more doubts? Now ಏನ್ ಮಾಡ್ಬೇಕೀಗಂದ್ರೆ ಲೆನ್ಸ್ ಮೇಲೆ ಸ್ವಲ್ಪ ವರ್ಕ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಫ್ಯೂ ವಿಡಿಯೋಸ್ ಆನ್ ಯೂಟ್ಯೂಬ್ ಮೇಲೆ ಸಿಕ್ಕಾಪಟ್ಟೆ ವಿಡಿಯೋಸ್ ಇದಾವೆ. ಯಾಕಂದ್ರೆ ಈಗ ಜನ ಏನ್ ಮಾಡ್ತಾರೆ, 108 ಮೆಗಾ ಪಿಕ್ಸೆಲ್ ಅಂದ್ರೆ ಮೊಬೈಲ್ ಕ್ಯಾಮ್ರಾ ಚೆನ್ನಾಗಿದೆ ಅಂತ ತಗೋತಾರೆ. These megapixel or pixel doesn't define the clarity of the image. It is the sizing. iPhone ನೋಡ್ರಿ, iPhone 12 ಮೆಗಾಪಿಕ್ಸೆಲ್, ನಿಮ್ ಆಂಡ್ರಾಯ್ಡ್ ಫೋನ್ ಇಂದು 108 ಮೆಗಾಪಿಕ್ಸೆಲ್. ಕಾಂಪಿಟೇಷನ್ ಹಚ್ಚ್ರಿ, ಆ 12 ಮೆಗಾಪಿಕ್ಸೆಲ್ ಗೆಲ್ಲೋದು. ಕ್ಲಾರಿಟಿ, ಶಾರ್ಪರ್, ಡೀಟೇಲ್ಸ್ ಇವೆಲ್ಲ ಐಫೋನ್ ಅಲ್ಲಿ ಕ್ಲಿಯರ್. ಯಾಕೆ ಕ್ಲಿಯರ್ ಬರ್ತಾವ ಅಂದ್ರೆ ಇಟ್ ಹ್ಯಾಸ್ ಅ ಲಾರ್ಜ್ ಸೆನ್ಸರ್ ದೊಡ್ಡ ಇರ್ತದೆ. ಎಷ್ಟು ದೊಡ್ಡ ಸೆನ್ಸರ್ ಆಗ್ತವೆ, ಇಟ್ ಅಲೋ ಸೋ ಮಚ್ ಆಫ್ ಲೈಟ್ ಟು ಎಂಟರ್, ಲೈಟ್ ಒಳಗಡೆ ಎಂಟರ್ ಆಗಕ್ಕೆ ಕೊಡ್ತಾರೆ. ನಮ್ಮ ಏನಿಲ್ಲ, ಇಷ್ಟಿಷ್ಟೇ ರೌಂಡ್ ಇರ್ತದೆ. ನೋಡ್ರಿ ಬೇಕಾದ್ರೆ ಐಫೋನ್ ಕ್ಯಾಮ್ರಾ ಲೆನ್ಸ್ ನೋಡ್ರಿ, ಇಷ್ಟು ದುಡ್ಡು ಇರ್ತದೆ. ಬರೀ ಕವರ್ ಹೇಳತ್ತಿಲ್ಲ, ಅದ್ರ ಒಳಗಿನ ಲೆನ್ಸ್ ನೋಡ್ರಿ ನೀವು, ಯಾರು ಬಿಗರ್. ಆದ್ರೆ ನಮ್ದು ಇಷ್ಟೇ ಇರುತ್ತೆ, ಇಷ್ಟೇ 108 ಮೆಗಾಪಿಕ್ಸೆಲ್ ಅಂತ. ಮೆಗಾಪಿಕ್ಸೆಲ್ ಈಸ್ ಓನ್ಲಿ ಫಾರ್ ದ ಸ್ಕ್ರೀನ್ ಸೈಜ್, ಝೂಮಿಂಗ್ ಕೆಪಾಸಿಟಿ. ನೀವು ಫೋಟೋ ಹೊಡೆದು ಝೂಮ್ ಮಾಡಿದ್ರೆ ಅಷ್ಟು ತನ ಒಡೆಯಲ್ಲ ಅಂತೇಳಿ, ಅಂದ್ರೆ ಪಿಕ್ಸಲೇಟ್ ಆಗೋದಿಲ್ಲ ಅಂತೇಳಿ ಕೊಟ್ಟಿರ್ತಾರೆ. ಬಟ್ ಡೀಟೇಲ್ಸ್ ಕಲೆಕ್ಟ್ ಮಾಡೋದಿರ್ತೈತಲ್ಲ, ಟು ಕಲೆಕ್ಟ್ ದ ಡೀಟೇಲ್ಸ್, ದಟ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಹ್ಯಾವ್ ಯು ಸೀನ್ ಎ ಡಿಜಿಟಲ್ ಕ್ಯಾಮ್ರಾ ಆರ್ ದ DSLR ಕ್ಯಾಮ್ರಾ? ನೋಡಿಲ್ಲ ಅಂದ್ರೆ ಸ್ಪಂದನಾ ಅಂಗಡಿಗೆ ಹೋಗಿ ಗೊತ್ತಾಗ್ತದೆ. ಫಾದರ್ ಇಸ್ ಎ ಕ್ಯಾಮ್ರಾ. ದೇ ವಿಲ್ ಬಿ ಹಾರ್ಡ್ಲಿ ಜಾಸ್ತಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಂದ್ರೆ 40 to 48 ಮೆಗಾಪಿಕ್ಸೆಲ್ ಇರ್ತವೆ. ಅದ್ರ ಲೆನ್ಸ್ ಇಷ್ಟು ದೊಡ್ಡ ಇರ್ತವೆ. ಯು ಕ್ಯಾನ್ ಸಿ ನೋ ಬಿಗರ್ ಲೆನ್ಸಸ್. ಎಷ್ಟು ದೊಡ್ಡ ಲೆನ್ಸು ಅಷ್ಟು ಕ್ಲಿಯರಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅಷ್ಟು ಲೈಟ್ ಒಳಗೆ ಹೋಗುತ್ತೆ ಅದ್ರೊಳಗೆ. ಸೋ ಮಚ್ ಆಫ್ ಲೈಟ್ enters it and falls on the sensor converts that light into electric signals, adane memory ದಾಗ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ. But mobile cameras are very small, tiny. They allow only limited amount of light to enter. So ಅಷ್ಟೇ ಲಿಮಿಟೆಡ್ ಲೈಟ್ ದಾಗೆ ಡೀಟೇಲ್ಸ್ ತಗೋಬೇಕಲ್ಲ. ಡೀಟೇಲ್ಸ್ ಅಂದ್ರೆ ಏನು, ಗಿಡ ತಗೊಂತು ಅದ್ರ ಒಳಗಡೆ ಎಲೆದ್ದು ಎಡ್ಜಸ್ ಒಳಗೆ ಸೈಜ್, ಅದ್ರೊಳಗಡೆ ಲೈನಿಂಗ್ಸ್ ಇರ್ತವೆ, ಆ ಲೈನಿಂಗ್ಸ್ ನಾಗ ಶೇಡ್ಸ್ ಇರ್ತವೆ. ಬೆಳಕು ಬಿದ್ದಲ್ಲಿ ಡಾರ್ಕ್ ಗ್ರೀನು, ಲೈಟ್ ಇದ್ದಲ್ಲಿ ಲೈಟ್ ಗ್ರೀನ್. These are called the details of the image. Details of the image cannot be taken clearly if your mobile camera do not have a proper sensor, which is nothing but the lens itself. So lens has to be proper. I hope it is clear. ನೋಡ್ರಿ, ಇದೆಲ್ಲ ಹೆಂಗೆ ಸೈನ್ಸ್ ಇಂಪ್ರೂವ್ ಆಗ್ಕೊಂತ ಹೋಯ್ತಲ್ಲ, ಹಂಗೆ ಟೆಕ್ನಾಲಜಿ ಇಂಪ್ರೂವ್ ಆಗ್ಕೊಂತ. ನಮ್ಮ ಅರ್ಲಿ ಡೇಸ್ ನಾವು ಕಾಲೇಜ್ಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಈಗಿನ ಫ್ರಂಟ್ ಕ್ಯಾಮ್ರಾ ಇದಾವಲ್ಲ, ಈ ತರ 10% ಎಫಿಷಿಯನ್ಸಿ ಇರಲಿಲ್ಲ. We had only 2 megapixel camera. We did not have any type of different sensors in the mobile. ಏನು ಸೆನ್ಸರ್ಸ್ ಇರಲಿಲ್ಲ ಆ ಫೋನಲ್ಲಿ. ಈಗೇನು ಆಕ್ಸಿಲರೋಮೀಟರ್ ಅಂತೆ, ಗೈರೋಸ್ಕೋಪ್ ಅಂತೆ, we have different sensors in the phones. Because our science is improving, technology is also improving. Isn't it? OIS ante, optical image stabilizer ante. You should see this. ಒಂದು ಫೋನ್ ತಗೋಬೇಕಾದ್ರೆ ಇವನ್ನೆಲ್ಲ ವಿಚಾರ ಮಾಡಬೇಕು. Optical image stabilization. Have you heard this?
No,
ಹೇಳಿದ್ರೆ
sir.
ಎಲ್ಲಾದ್ರು OIS, EIS ಇವೆರಡು ಫೀಚರ್ಸ್ ಇರಬೇಕು ಫೋನಲ್ಲಿ. EIS is electronic image stabilization. OIS ಅಂದ್ರೆ optic image stabilization. ಒಂದು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಹೇಳ್ತೀನಿ. ಲಾಸ್ಟ್ 2019 December we had been to Rajasthan. Thar desert ಗೆ ಹೋಗಿದ್ವಿ. I was using the phone OnePlus 60 ನನ್ನ ಕಡೆ ಫೋನು. I was shooting. I and my friends all were sitting in that Jeep, Thar Jeep da gutta, Thar in Jeep.
Yes, sir.
Thar.
Yes, sir.
In back irlilla, we were standing on the top of it. It was so slant, so deep. Hinga hogi ebishi hogyatitta. ನನ್ನ ಮೊಬೈಲ್ ಅಲ್ಲಿ ಶೂಟಿಂಗ್ ಮಾಡಿದ್ದೆ. ಏನು ದಡಕಿ ಬಂದಿಲ್ಲ ಫೋನ್. ಎಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್. ಗಾಡಿ ಅಷ್ಟೇ ಅಳೆಗಾಡೋದು ಬಂದಿದೆ. ಎವ್ರಿಥಿಂಗ್ ಈಸ್ ಸೋ ನೀಟ್ ಅಂಡ್ ಕ್ಲಿಯರ್. Because that mobile had this optical image stabilizer. Sometimes ಏನ್ ಮಾಡ್ತೀವಿ, ಶೂಟಿಂಗ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ತಗೊಂಡು ಓಡ್ತಿರ್ತೀವಿ. ಓಡ್ದಾಗ ಹಿಂಗೆ ಅಳೆಗಾಟ ಬಿಡ್ತಿರ್ತೀವಿ. ಕ್ಯಾಮ್ರಾ ಅಳೆಗಾಟ. It will not stabilize. So stabilizers are important. OIS stabilizer, EIS stabilizer. ಫೋನಲ್ಲಿ ನೋಡಿದಿರಲ್ಲ, ಅಲ್ಟ್ರಾ ಸ್ಟೆಬಿಲಿಟಿ ಅಂತ ಒಂದು ಆಪ್ಷನ್ ಇರುತ್ತೆ. ಎಸ್ಪೆಷಲಿ ಇನ್ ದ ಸ್ಯಾಮ್ಸಂಗ್ ಫೋನ್ಸ್ ಎಲ್ಲ. ಇವು ಯಾವ ಒಪ್ಪೋ, ವಿವೋ ಇವೆಲ್ಲ ತಗೋತಿರಲ್ಲ, ಅದರೊಳಗೆ ಏನು ಸಿಗಲ್ಲ ಇದು. ನಿಮ್ಗೆ 5,000, 10,000, 15,000 ಮಟನೂ ಸಿಗಲ್ಲ ಇದು. 20,000ಕ್ಕೂ ಸಿಗತ್ತಿಲ್ಲ ಇವತ್ತು. You have to purchase above 25,000, then you will get these options. ಸೊ ಯಾರಾದ್ರೂ ತಗೋತಾ ಇದ್ರೆ ಇವನ್ನೆಲ್ಲ ಫೀಚರ್ಸ್ ಚೆಕ್ ಮಾಡಬೇಕು, ಯಾವಾಗ ಹುಡುಕಬೇಕು. ಇಂಟ್ರೆಸ್ಟೆಡ್ ನೀವು ಸೈನ್ಸ್ ಗೊತ್ತಿರೋ ಹುಡುಗರು ಇವನ್ನೆಲ್ಲ ಚೆಕ್ ಮಾಡಿ, ಕ್ಯಾಮ್ರಾ ಸೆನ್ಸರ್ ಎಷ್ಟಿದೆ, ಎಷ್ಟು ಮೈಕ್ರೋನ್ ಪಿಕ್ಸೆಲ್ ಇದೆ, ಇವೆಲ್ಲ ಚೆಕ್ ಮಾಡಿ then you can purchase. Okay, that's it. If you have any doubt, you can ask.